Hello, geometry students. It is time for section 3.3. I feel pretty strongly that 3.3 is going to be a review section. Notice the title, Slopes of Lines. So we're going to talk about slopes really quickly, and then we're going to talk about parallel and perpendicular slopes. I'm hoping that this is a throwback to algebra. If not, we'll fill in those blanks. So first of all, I think everybody knows what slope is. If we're being technical, it's a ratio. Ratios are fractions, right? Ratio of the change in y over the change in x. Here is your mathematical symbol, right? Over is divide. Rise over run is how a lot of people think of it. And if it is graphed, feel free to count the rise, so the change in y's, over the run, the change in x's. You can count those. And in the real world, it's a unit rate. Slope, think about if you have a job or if you want a job and you make an hourly rate. Every hour you make, say you make 10 bucks an hour, every hour you make an extra $10. So $10 for every hour would be your slope. If you like rise over run on a graph, that's great, count it out. If you like a formula, our formula is m equals slope. The letter we use for slope is m, throwback to years ago. We do y2 minus y1 over x2 minus x1. It looks similar feeling for distance formula. Subtract the y's over subtract the x's is how I always say it. Remember, your x1, y1 is one ordered pair, your x2, y2 is another ordered pair. So that formula is going to come in real handy. So got some practice. So it says determine the slope of each line, calculate or use rise over run. So I don't care which way you do. Typically, because I'm kind of lazy, if it's graphed for me, I'm going to count rise over run. If it is just given to me as ordered pairs, I'm going to do the formula. Do whatever makes you happy. I'm going to do one of each way. So let's do this first one is rise over run. So from this point right here to this point right here, how far up do we go? 1, 2, 3, 4 units, right? And then the run or across is 1, 2, 3, 4, 5, 6. So rise over run is 4 units over 6. Of course, everybody's going to simplify that down to 2/3. Yes, you must simplify, and yes, keep it as a fraction. Number 2, let's calculate that just because I want to do an example of each. So we're going to need to know what the ordered pairs are. It looks like this is at 2, 2, 5 is this ordered pair, and over 3 up 0 is this ordered pair. So I'm going to call that my x and y's, 1s and 2s. So this is the first ordered pair. This is the second ordered pair. Notice this line is going down if you read from left to right. So we're going to have ourselves, we should have a negative answer, right? So m is equal to, I'll put it up here, y2 minus y1 over x2 minus x1. So I'm going to do a change in y's. Make sure you put the y's on the top. That's always the error that people make when you're in a rush. So I don't want you to mess up. So 0 minus 5, because y2 minus y1, 3 minus 2. So I end up with a negative 5 over 1. Or, if you prefer, our slope equals negative 5. If it was 5 over negative 1, if you did it in the other order, remember, it's the same thing. 5 over negative 1. If you divided that out on your calculator, you'd get negative 5. Anything over 1, you can put the negative on the top, the bottom, or out in front. It's all a negative value. It makes sense that it's negative, right? Because that line is sloping downward, whereas in problem number 1, the line was sloping upward. Let's skip 3 and 4 because we're going to talk about these right now. I really like this box. This is a good go-to box. So let's say a couple things about each one of these. Positive, negative, 0, and undefined. We just looked at a positive and a negative. Positive slope means I'm just going to draw on some kind of line. Don't forget to put your arrows on each end. It is, we'll say, sloping up. Usually when I first ask about slope, a lot of people say, or I could say ascending if I wanted to. A lot of people say y equals mx plus b. Well, the m in that formula is the slope, right? So we're going to use that. Y equals mxb isn't the slope. Slope is a part of that formula. Negative slopes. We are sloping downward. So something like this. We could make it as steep or not as steep. Sloping downward. So when you read left to right, it is going down. So your m value is going to be positive. Sorry, in a positive slope, your m value is positive. In a negative slope, maybe I should write that the other way. I'll say positive m. This one, you're going to have a negative m value. 0 and undefined slopes are very interesting. Let's just draw those out. 0, remember, rise over run. 0 slope means that it's not rising at all. A 0 slope is simply a horizontal line. In an equation, your slope would be 0. There would be no slope at all. And one important thing, so what that looks like for an equation, I would write this down because I feel like this is really an important fact. If you see an equation that just says y equals something, like say y equals 3, I'll put a b here. There is no x in the equation. That's a 0 slope. It's a horizontal line because technically that's y equals 0x plus b. We don't have any x's. There's none of them. It's 0. So this equation right here that I drew might be something like y equals 3. No x's. It's just a horizontal line. We're going to refer back to that. Keep this page. This is important with this information. Last but not least, undefined slope would be a vertical line. And anytime you see an equation, this is the really weird looking one. This means that it rises, but it never runs, right? It never goes across the page. It only goes up and down the page. So this one, if you ever see an equation that is like x equals something, whatever it might be, I'll just say a, some value, there's no y's in the equation at all, that's an undefined slope. That is a vertical line. This equation right here might be y equals -2. Notice there's no x's. Save this. This is important. When we get to horizontal and vertical and they say it that way, you're going to need to know, oh, it's a horizontal line. That means that the slope is 0. That means it's just a y equals. Here's how I remember this. It's kind of a dumb little thing, but it helps me. If it's only a y in the equation with no x's, I remember that it goes through the y-axis. If it's only an x in the equation with no y's, I remember it goes through the x equation because there is no y. It never touches y. So it helps me. I don't know if it'll help you, but we can go from there. So let's skip this. Let's get right to parallel and perpendicular lines. Now we've talked about parallel lines already, right, in sections 3.1, or well, I guess section 3.2. Remember parallel lines, we always look for our extra little arrows here. And there is something very particular. If we've got two lines on a graph and they are parallel, something super important, I don't know if you notice over on the diagram, I circled both of those parallel arrows. And if I look at the slopes of both of them, they both have a slope of 4 or 4/1. Parallel lines have the same slope. Parallel lines have the same slope. By the way, I should probably mention the symbol for parallel. Parallel, we could say in this case that L and M are parallel. So we say a small cursive L is parallel to a small cursive M. So the sign for parallel is like two vertical parallel lines. The all vertical lines are parallel is kind of just like fine print because they have undefined slopes, and so we can't really compare numbers like 4 and 4. Horizontal lines have a slope of 0. 0 and 0 are the same thing. So that's why they put that in there. Basically, if it's undefined, and another one's undefined, they have the same slope, right? They are both undefined. Perpendicular lines. Notice right here I've got a right angle box. So if I compare my slope from my perpendicular line, this negative 1/4, to the slopes of the two parallels, 4, there is a pattern here. I don't know if you know it. I hope you do. But perpendicular lines have a negative reciprocal slope. Be careful on the negative. It means opposite. I'll put opposite in parentheses here. So if one is positive, the other has to be negative. If one is negative, the other has to be positive. So the technical term is they have a negative reciprocal slope. I like opposite because it's opposite sign of what the one was. So I've got 4 and negative 1/4. One's positive, one's negative. And then reciprocal, do you remember reciprocal? Reciprocal is the flipped over fraction. So slope of negative 1/4, I flip that over, I get 4/1. Remember, when you've just got a slope of 4/1, or just 4, it would be like a 4/1. So when you do the reciprocal, it's 1/4, and then I change the sign. Horizontal and vertical lines are perpendicular, so basically 0 and undefined are perpendicular slopes, even though they don't have numbers in there for the undefined. So there's a symbol for this as well. So our example here, here's line P. I'm going to say that line P is perpendicular to line L. I could say P is perpendicular to M, whichever one you prefer. So we're going to do things with those same slopes for parallel and opposite reciprocals for perpendicular. So you need to kind of understand what those mean and what they are. So watch for those two things. So let's do a quick example here. It says determine whether AB, and I should have put a line above this, line AB and line CD are parallel, perpendicular, or neither. So it's a question. It's saying which one of those three is it? Let's just do example A. Let's not do B, so feel free to use space or do that on your own. It's telling me I've got a line AB. So these two guys I need to work together. And it's telling me that CD is its own line. So this is two separate problems right here. Well, in order to tell if they're parallel, perpendicular, or neither, I need to find the slope, right? Then I can compare them. If I graph them, I can get a pretty good idea, and some people do like to graph them, but I still need to see what the slope is. So if you graph, you still have to write down m equals whatever, count your rise over run. So if I'm going to find the slope of line AB, I'm going to call this an x and y, 1 and 1, an x and y, 2 and 2. I'm going to do my slope formula, subtract the y's over subtract the x's. So 7 minus negative 5 and 4 minus negative 2. So that's going to be like a 12/6. Of course, everybody's going to simplify and tell me that that's a 2 or a 2/1. Now, if CD comes out with a slope of 2, we know it's the same, so they're parallel. If CD comes out with a negative 1/2, because I flipped that 2/1 over and made it a negative, then I know they're perpendicular. Otherwise, I know that they're just two random numbers or two random lines sitting out there that intersect, but I don't know if it's a 90-degree angle. So I'll call this x and y, 1 and 1, x and y, 2 and 2. So let's find the slope of this one. So subtract the y's on the top. So negative 2 minus 2 is not 0. 8 minus 0. So negative 2 minus 2 is negative 4/8. Simplify that down. Hopefully you can see, remember this is like 2/1. So opposite signs and reciprocals. So these two lines, AB and CD, are going to be perpendicular. So you have to find the slopes in order to compare to see if they're the same, if they're opposite reciprocals. If they're not either of those two things, they're just two random lines, you can say they're neither. I'm going to ask you to do some problems like that, so hopefully that helps you out. I also am going to ask you to do some problems that already pre-graphed and just ask about the slope or ask about what line is parallel or what is the slope of this line. So you're just going to go to the graph and probably count rise over run, find another line that has the same rise over run if it's parallel, find, the opposite reciprocal. So there are some pre-graphed ones where I don't ask you to do the work or ask you to find the slope. Watch out for those guys. And let's see, last but not least, let's do number 8. Let's skip 7. It's kind of the same idea. Number 7 asks for parallel, number 8 asks for perpendicular. So number 8, it says graph a line that contains point P, which is at 0, 1, and it is perpendicular to the line QR, and it tells us what Q and R are. So you don't necessarily have to graph QR if you don't want to, but let's do that so we can see what it looks like. And then we have to remember perpendicular, and I'm going to need to know slope. I feel pretty sure that I asked you a question like this on a quiz or a test. I can't remember which one, but I know that I asked you to graph and to show this. So let's start with line QR. I'll worry about P in just a second, even though it came first. So Q's at -6, -2. Please put the points on there. It really helps. R is at 0, -6. Remember, it's across first, up and down second. So here is line QR. I want to make a line that's perpendicular. Well, what's the slope of QR? I need to be super technical about this. So QR slope. If we do rise over run, or if you do the formula, it doesn't matter. We should still get the same answer, right? So let's see, I'm going to count because it's graphed for me. So I go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So down 4, everybody knows that's a negative, right? Down 4 and right 6. If I simplify that, that's going to be a -2/3. Keep it as a fraction. On a graph, it actually makes it easier even if you're scared of graphs. So if I want to do a perpendicular, I want it to be perpendicular to -2/3. So if my slope of QR is -2/3, what is my slope of my new line going to be? What's perpendicular to -2/3? Opposite reciprocal. So switch the sign, flip the fraction over, write down what you say it is. This is what I say it is. I'm going to say a +3/2. I don't care that it's an improper fraction. I just care that I can get that on the graph. So I have to graph a line with a slope of 3/2. And I need it to go through point P. So it's basically point P is giving me a starting place. So I'm going to go to over 0, up 1. I'm going to call this point P. And then I'm going to start graphing from there. I'm going to go up 3 and right 2 because it's a positive slope. So everything goes up and to the right. 1, 2, 3 over 2. 2, 3 over 2. I could keep going forever. If you run out of space or if you wanted to cross line QR instead of going up 3 and right 2, everybody knows what you could do, right? You could go down 3 and left 2. Look at how it continues from the line you already had. Down 3 and right 2. Down 3 and right 2. I will send some, make sure there's graph paper available as well. So if I connect these dots, I wish I had a straight edge. It's a little sloppy. That definitely looks like a right angle. I could even put a right angle box there. So on a quiz or a test, I am technically looking for line P, or the line that contains point P. If I have the line with R, that's great, with Q and R. But point P was the line that I asked you to graph. So we do the same thing for number 7. I would find out the slope of line CD. Slope equals. And then I would use that if it's parallel. I'm going to use the same slope, whatever that comes out to, and I'm going to put point A and use that as my starting point with my parallel slope. And it should run parallel. It should never intersect the line CD. All right, hopefully that helps out. Hopefully there was a lot of review stuff. And we'll do some graphing and some identifying, and then when we move into 3-4, we'll start writing some equations, and we'll finally get to use y equals mx plus b. That is it for section 3.3.